Let's practice some multiple choice questions. These questions are from the OCR specimen paper. However, many of them will be applicable to many exam boards. Okay, so let's start off with question one. We've got three lengths like so, and calculate Z by taking two of them. What is the best estimate of the uncertainty in Z? Just like Z physics. Well, the absolute uncertainty is always just added up. So we know that it's an absolute uncertainty because we have units. So the uncertainty in Z will just be the uncertainty of this one, which is 2, plus the uncertainty in this one. So add them together, we are going to get plus or minus 8 millimeters. Correct answer is D. Okay, next one, we've got a 2-meter rigid rod with negligible weight subject to forces. For the rod to be in equilibrium, which of the diagrams is or are correct? Okay, there's two conditions. Number one, the sum of all the forces has to be equal to 0. Basically, we have to balance them. All the upwards forces have to equal all the magnitude of all the downwards forces. But also the sum of all moments has to be 0 around any point. Okay, now let's have a look at this one. So the forces check out. We have 2 newtons going up, 2 newtons going down. The moments as well seem to check out because this one here is going to spin it this way, whereas, let's write it like that. This one here will spin it this way, and they're equidistant from here. So yeah, this one is in equilibrium. This one here, well, no, the moments are actually in the same direction, so they're going to produce a net moment. This thing will actually be spinning because if one force is kind of going up, the other one is going down, you are going to get rotation. Okay, next one, we have 2 newtons going up in either direction, and overall 4 newtons going up. No force is pushing it down, so it's no longer, so it's not going to be in equilibrium. So this one doesn't work, this one doesn't work. So to me, it seems that the only one that will work is 1. Correct answer is D. Okay, side note, but if you want to change a multiple choice answer, don't try and sort of scribble onto it. If you wanted to change an answer, just do that and write down the new answer. Question 3, the PD across the resistor is 12 volts. Now let me just double check. This is the sample question paper for modeling physics. If you're doing OCR, I think there's a little bit of an error in here. Electricity is definitely not tested in this form in modeling physics, but let's do this question anyways. So the PD across a resistor is 12 volts. The power dissipated is 6 watts. Which statement is correct? So we can immediately calculate the current because power is VI. The current will just be the power divided by the voltage, meaning that the current will just be half an amp. No. Okay, let's go for the statement. The charge passing through the resistor in 1 second is 2 coulombs. Nope. So in 1 second, because let's say that Q is IT, we can use that. The current is 0.5 times 1. It's actually half a coulomb. So the first statement is wrong. The resistor transfers 6 joules for each coulomb passing through the resistor. This one here is also wrong because voltage is work done or energy per unit charge. So for 1 coulomb, if this here is 12, we're going to have 12 joules. So this one here is wrong. The resistor transfers 12 joules in 2 seconds. Well, in 2 seconds, we are going to have 1 coulomb of charge because Q is equal to IT. So it's going to be 0.5 times 2. So we're going to have 1 coulomb like that. So if we have 1 coulomb in 2 seconds, the voltage will be equal to W over Q, meaning that W will be VQ, meaning that the energy will just be 12 times 1. So yeah, this one here checks out. So this one here is correct. Correct answer is C. Okay, question number 4. We've got a spring with a force constant this much is placed in series. Basically, we have this arrangement, then we apply a force. What distance does point X move when the 0.6 force is applied? Okay, so we need to work out the total spring constant for this arrangement. So when the springs are in series, we're going to have 1 over 0.1 plus 1 over 0.2 raised to a power of -1. And this here will give me the total spring constant on the right. Let's put that into so this here will give me 0.066 reoccurring newtons per centimeter. So we're going to have this much on the left and this much on the right. So if the total spring constant on the right is also the same, then when they're in parallel, K total will just be K1 plus K2. In other words, this plus that, which is just equal to 2 times this number. Okay, so I'm going to multiply whatever I had in the calculator by 2, and that's going to give me 0.133 reoccurring newtons per centimeter. My final step will just be to use F is equal to Kx to work out the extension. So it's going to be 0.6, divide that by 0.133 reoccurring. Because this number here is reoccurring, we're actually going to get 4.5 centimeters. Okay, question 5. A group of civil engineers are assessing whether or not to use solid concrete pillars or hollow metal tubes. One such tube is shown below. So the word hollow in this question is really important. The tube is placed on a horizontal surface. The tube is made out of a metal of thickness T. It has a height H and a mean internal radius R. Okay, so if the tube is hollow, we're not going to be using a cross-sectional area to work out the approximate pressure in the standard way. So pressure is force over area, but rather than pi r squared, where we take this entire area into account, we are going to use for the area 2 pi r, which is the circumference, multiplied by that little infinitesimal thickness T. So that means that the pressure is equal to mg over 2 pi RT. If it wasn't hollow, the correct answer will be D, but it is hollow, therefore the correct answer is A. Okay, next one, we've got a train consisting of 6 trucks, each of mass 6 times 10 to the power 24. It's put at horizontal speed by a locomotive along a straight. The horizontal forces resisting the motion of each truck is 4,000 newtons. The coupling between trucks 2 and 3 snap. What is the initial acceleration? Question 6, I really like this one. We've got a train consisting of 6 trucks, each of them with a mass of 6 times 10 to the power 4, is pulled at a constant speed by a locomotive of mass 24 times 10 to the power 4. The horizontal forces acting on the motion of each truck is 4,000. The coupling between trucks 2 and 3 snaps eventually. Okay, so initially this thing was being pulled at a constant speed. So this means that all of the forces have to balance out, that the net force initially is 0. So this means that the driving force has to be equal to the total resistive force, which is going to be 4,000 times 7, because each of them is going to experience 4,000 newtons of resistive force. So that means that the driving force is going to be 28,000 newtons. Now, after this thing is snapped, we're going to have 3 of them, like so, and that force of 28,000 newtons will still be pulling them. Okay, now the total mass will be 24 times 10 to the power 4. That's for the first one. And then the second and third, each of them have a mass of 6.0 times 10 to the power 4. So the total mass will be this times 2. We need to take away, though, the drag force, because each of them also experiences 4,000 newtons, sort of this way, this way, this way. So we're going to need to take away another 12,000 newtons. So this means that our equation will be that F net is equal to MA. Our net force will be 28,000. Take away 4,000 times 3. And this here will be equal to our total mass, which will be 24 times 10 to the power 4 plus 2 times 6 times 2 times 6 times 10 to the 4 multiplied by the acceleration. Okay. So this is getting a little bit messy, but all we need to do is just rearrange for the acceleration, which will be 28,000, take away 12,000, divide that by this number. And if we do that, we're going to get 0.044 reoccurring meters per second squared. Correct answer. Okay, question 7. This is a tricky one. We've got a sandbag dropped from a balloon hovering 1.3 meters above the ground. It hits the ground at 5 meters per second. On another occasion, the sandbag is released from the balloon, which is rising at 7 meters per second when it's 1.3 meters above the ground. Okay, so the trick about this is that in the second situation, the ball will actually be going, the sandbag will initially be going up because it was moving at 7 meters per second upwards. So we need to slow down first, reach its maximum height, and then start falling again. What will the maximum height be until we get rid of that upward speed of 7 meters per second? So in the vertical direction, I've used v squared is equal to u squared plus 2as, and that's going to give me, if we set the final speed equal to 0 to work out the maximum height, we're going to get that the maximum height is 2.5 meters, with g now being minus 9.81. Okay, so that is a maximum height of 2.5 above the 1.3 meters when it was released. So the total height in the second case, from when the sandbag starts picking up speed again, will be 3.8 meters above the ground. Okay, now in that time, it will start to pick up speed, so we can use v squared is equal to u squared plus 2as, and that's going to give me 0. Now g is positive, plus 2 times 9.81 multiplied by 3.8, and that's going to give me 8.63 meters per second when this thing is about to hit the ground. But that's only the vertical speed. It also has some horizontal speed, which is unchanged. We assume there's no air resistance. In this case, it doesn't mention it, so we're going to have to, so for the final answer, we're going to have to do that the total speed, let's say v total, will be the square root of 8.63 squared plus 5 meters squared, and if we do that, we're going to get around 9.97 meters per second, around about 10 meters per second. Correct answer is C. Okay, next one. A piece of flat A4 paper is dropped and falls to the floor. The same piece of paper is then collapsed into a ball and dropped again. Which of the following will change in the second situation? So the same piece of paper is then collapsed into a ball. The maximum magnitude of the air resistance. Well, the maximum magnitude of the air resistance will always equal to the total amount of weight, which in this case is unchanged. It's just that the shape is unchanged. The weight of the paper will be unchanged, but the time taken to reach terminal velocity will change because the drag force will be drastically different. It will fall a lot paper. The initial acceleration will be g as well. So yeah, correct answer is C. Okay, question 9. A small amount of copper is heated in a container. The copper starts to melt. Which statement about the melting of the copper is correct? So the temperature is constant during melting, so we know it's either going to be A or C. If the temperature is constant, the kinetic energy cannot increase. However, the potential energy does increase. Correct answer is C yet again. Question 10, which is the correct unit for specific heat capacity? So because E is equal to mc delta theta, this means the specific heat capacity will be energy divided by m delta theta. These are base units, so the base unit of energy is, we can just derive that from a half mv squared, for instance. So half has no units, mass is measured in kilograms, meters per second, so it's going to be m squared s to a power of -2. Okay, so that's going to be kilograms, meters squared s to a power of -2 divided by kilograms, and change in temperature, that's just measured in Kelvin. Okay, so what will that give me? That will just give me m squared s to a power of -2 k to the power of -1. That seems like A to me. Okay, let's have a look at the next question 11. This is about Betelgeuse, a star in the constellations which could undergo a supernova explosion, which could then Betelgeuse evolve into. Out of these, the only possible answer is a neutron star. It will either be a neutron star or a black hole. Correct answer is B. Okay, 12. Stars emit EM radiation. A graph of the intensity against wavelength for a main sequence star is shown. Which statement is correct as the main sequence stars evolves into a red giant? The peak wavelength does not change. No, it does change. The star changes color, so the peak wavelength will actually get reduced, because wavelength, the red wavelength will have a longer wavelength, and if it has a longer wavelength, well, it's increasing this way. Therefore, the correct answer has to be D, because the peak wavelength has moved to the right. It's increased in size. It's gone, let's say, from yellow to red, meaning that the correct answer is D. Okay, next one, question 13. When light from a star is passed through a diffraction grating, it forms a spectrum. Which of the following statements are correct? Okay, well, first one, light emitted from the surface of a star would form a continuous spectrum. Now, the key word here is emitted. So if it's emitted from the star, it will be under a continuous spectrum. So the sun, for instance, emits across all of the wavelengths. Some of them will be absorbed in the solar atmosphere, though. So this one here seems correct to me. Question 2. Light received from the sun has dark lines across its spectrum which correspond to the absorption of certain wavelengths by atoms in the Earth's atmosphere. Absolutely not correct. They correspond to the absorption by certain atoms in the sun's or the star's atmosphere. A photon emission spectrum occurs when an electron moves from a low to a higher energy level within the atom. It's actually the opposite. It occurs when emission occurs when we go from a higher to a lower. So I'm going to go with D, only one. Okay, 14. A star has a surface temperature of 3000 degrees Celsius and velocity L. Another star of identical size has a surface temperature of 2500 degrees C. What is the luminosity in this star in terms of L? So let's just write down Stefan's law. Something to keep in mind is that these need to be in Kelvin in Stefan's law. So this here will be equal to 4 pi r squared times Stefan's constant and then t to the power of 4. Okay, so everything else seems identical except for the temperature. So the temperature, let's see by what factor it will actually rise. Well, let's convert these to Kelvin first of all. So this one, let's see what's happened here. 3000 will be equal to 3273 Kelvin, and this one 2773 Kelvin. Basically, I've just added. I think probably the easiest way to tackle these questions is in terms of a ratio. So I'm going to go L1 over L2 will be equal to 4 pi r squared. All this stuff is going to essentially get cancelled in a minute. 4 pi r squared, Stefan constant t squared raised to the power of 4. Okay, now look at this. Now what we need to do is find the luminosity of the second star in terms of L, where L1 was essentially L. Okay, so I'm going to say that that I'm going to bring L2 here, and then I'm going to just simply rearrange for it. So I'm going to go that L2 will be L1 multiplied by T2 raised to the power of 4 over T1 raised to the power of 4. Okay, now T2 was 2,500 plus 273, so that'll be 2,773 raised to the power of 4 over 3,273 raised to the power of 4. And this here will just give me an answer of around 0.515. Let's call it 0.52 L1. I've just called L1 to be L. Seems to me like the correct answer is B. Okay, question 15 is pretty difficult. We have scientists applying to launch a rocket from the surface of the Earth into an orbit at a distance of 18,000 kilometers above the center of the Earth. The radius of the Earth is 6,400 kilometers, and it has a mass of 6.0 times 10 to the power 24 kg. What is the minimum work done to move the 150 kilogram mass of the rocket into the orbit? Well, this here will be the sum of two things. It will be the sum of the change in GPE. Let's work out the change of GPE, and then on top of that, we need to add the kinetic energy, because if we only had the change of GPE, then the satellite will kind of reach there and then will retract back into the Earth. We want to give it some velocity as well, because the total energy of a satellite is GPE plus the kinetic energy. So the change of GP will be given by 6.67 times 10 to the 11 GMM, 6 times 10 to the power 24 is the mass of the Earth, times 150, minus 1 over R2, which is the distance 18,000 kilometers above the center of the Earth, plus the radius of the Earth, which was the original point where the satellite was. And if we add that, that's going to give me 6 times 10 to the 9. Now, on top of that, we need to add the kinetic energy required to keep the satellite in this orbit, because this has to come from somewhere. So this here will be given by half mv squared. How do we know the orbital speed of that satellite? Well, remember, gmm over r squared has to be equal to mv squared over r, meaning that the square of the orbital speed, v squared, would just be gm over r. So the kinetic energy of the satellite at that point will be a half mv squared, where v is this expression, meaning that we get a half m gm over r, which is a half times 150 times 6.67 times 10 to the minus 11 times 6 to the 24, and then divided by that number. Now, if we add the potential energy plus this expression, we are going to get, I've just done that into the calculator, we are going to get 7.7 times 10 to the 9 joules. Now, my problem with this question is that it assumes that the rotational energy initially is 0, but if this thing is being fired off from the equator, we're going to need to take away the kinetic energy that it already has due to the rotation of the Earth. So I believe the mark scheme is not 100% accurate, but let me know what you think in the comments. Okay guys, hopefully this was useful. If you'd like to see more multiple choice questions, I have more over here. Enjoy.